Welcome to part 2 of this series on shorebird plumage and molt. Before we get into the details of different plumages and molts, it's important to understand some characteristics of feathers themselves and how different factors can affect their durability, appearance, and so on. I'll limit the scope of this video to factors which are useful in field identification. So the learning outcomes for this video are that you will better understand how regular wear and tear affects the appearance of feathers, and then that you would be able to use this information to help you age shorebirds. So let's start with some basic functions of feathers. In no particular order, there is heat regulation, keeping the bird warm enough in cold conditions and being able to dissipate heat in extreme high temperatures, keeping the bird cool enough. And it's feathers that enable birds to do this. Chicks in downy plumage lack this ability, so they need to be constantly sheltered by the parent birds, as we can see in this photograph, a female Malaysian plover sheltering her chicks from the sun. Healthy feathers are also water resistant to some extent, and this also enables the bird to maintain body heat. The second function of feathers is camouflage, staying hidden from predators and also potential prey. Most shorebirds have mud-colored upperparts during the non-breeding season to minimize the chance of detection from above. When an aerial threat is detected, such as a raptor, they'll often crouch down to minimize any telltale shadows and also to reduce the visibility of their white underparts. Conversely, the white underparts possibly makes them harder to see from the point of view of their marine prey. So a marine prey item underneath the surface of the water looking up towards the sky may not be able to pick out a white belly of a shorebird so easily as if it were dark. A third function of feathers is display and courtship. During the breeding season, shorebirds still want to remain inconspicuous to potential predators, so they often have cryptically patterned upperparts, but they also want to be noticed by a potential mate, so they assume bright colors on the head and underparts especially. And there's some evidence that brightness of plumage plays a role in mate selection in some species. The last basic function of feathers is, of course, flight. Not all birds can fly, not even all shorebirds, but flight is one of the most distinctive characteristics of birds, and feathers, and in particular the condition that they're in, clearly play a critical role, especially for the majority of shorebirds, which, as we know, are long-distance migrants. Now let's look at feather structure. So here is a secondary from an adult greater sand plover. We can see that the base of the feather has these loose and fluffy plumes, which presumably help to trap air close to the body and therefore aid insulation. The central backbone of the feather is the quill and the shaft of the feather. The quill is where the bird is, how the feather is attached to the body or the skin of the bird. And then these downy plumes at the base, which are often white or pale, and they don't have any barbs on them, so they don't stick to each other. They're non-interlocking. As we move further up the feather, we can see that the plumes have, if you look under a microscope, you can see that they have these hooks or barbs on them which enable them to stick together, and they're also infused with pigment, melanins, which give them their color but also strengthen the feathers, so they become stronger toward the tip. And it's this part of the feather which is exposed to some degree to the elements and is therefore susceptible to wear and tear. I'll just point out another couple of features of this feather. The tip of the feather, which in this feather, in many feathers, is paler, and also the feather shaft, which is the strongest part of the feather. So here we can see a variety of feathers from an adult greater sandplover, a scapula on the left, and then an undertail covert, and then two tertials, one which is worn on the left and a new or fresh one on the right. And what we can see is that they vary in shape considerably, but they are similar in structure, just like the feather I showed you in the previous slide. Here are some other variants, primary on the left, the secondary which we looked at, and then on the right a tail feather. New feathers are protected by a waxy sheath when they're growing, and they emerge from it. And new feathers typically are darker and also have a neat edge which has not yet been exposed to abrasion or bleaching. By contrast, the lower feather shows a significant amount of wear, but notice that it's not evenly on both sides of the shaft. The inner web is markedly fresh compared to the outer web, which is significantly worn. And the reason for that is to do with the amount of exposure that the different sides of the feather have. So if you can imagine, the tertial sits beneath another feather on top of it, which largely covers the inner web, and therefore it remains fresh and neat. The outer web is not covered by any other feather, and so it's exposed to the elements, and so it becomes very ragged and worn away with age. Why do feathers need to be changed anyway? Well, we've covered actually both the main reasons. Firstly, there are requirements connected to seasonal changes, the need to attract a mate, etc., and also the different habitats that the birds utilize in the non-breeding and the breeding season. So that requires a change of color. But also, feathers need to be changed because they experience damage. And simply put, if a bird doesn't molt, it will eventually die. In fact, studies show that molt is actually more important to the individual bird than any other function, including breeding. If they don't molt, they die. So they need to change their feathers regularly. Feather damage or wear has two naturally occurring causes: abrasion and bleaching. Abrasion occurs as shorebirds interact with their natural environments such as salt water, sand, wind, rain, etc. And bleaching is the effect of sunlight on the exposed feathers. And so bleaching makes the feather become paler, reduces the amount of pigment, and both of these factors, abrasion and bleaching, work together in weakening the structure of the feather and causing it damage. The weakest area of a feather is the area without pigment. So white or light areas of feathers are weaker than dark areas. So for example, on this scapula of a juvenile redneck stint, we can see that it has a white tip, and this will wear away faster than dark areas. Sometimes we can see this with flags. If you take a look at an old flag, you'll notice that the white areas tear and wear away more quickly than the colored areas, and again that's simply because the pigment strengthens the material. So here's an example of how feather wear may affect the appearance of the feather. You can see that the white tip is reducing, and now we can see that the feather shaft, the stronger part of the feather, is protruding beyond the tip or the edge of the rest of the feather. And when it's extremely worn, there's no white left at all. And also we can see the effects of bleaching occurring as the darker areas become less distinct. And if we multiply this over the whole bird, then it can have a major impact on the overall appearance. And it can explain why birds of the same species and the same age can look very different from one another. Here's an example. Here are the scapulars of a juvenile redneck stint, and this bird is in very fresh plumage. The condition of the plumage is very fresh. And here's another one, same species, same plumage, same month, but the condition of these feathers is that they're very worn. They've lost the white tips, and they've also become quite bleached, and so the black areas have become brown, and the contrast between the different coloration is considerably less. So here's what it looks like on the whole bird. So here's the bird with the feathers in fresh condition, and here is a bird with the feathers in worn condition. Same species, same plumage, same month, but looking very different from one another due to the effects of wear. Here's another feather showing how wear affects different parts of the feather at different rates. So here we can see a tertial of an adult wood sandpiper, and there are dark bars emanating out from the feather shaft, and there are white edges between the bars. So which parts do you think will wear away fastest? Yes, it is the white parts. And over time, this affects the overall shape of the feather, so it begins to have a zigzag contour. Here's how it looks on a real bird. So here are the tertials in fresh condition with these neat white triangles, and same species, same plumage, but in this case these tertials are very worn, and you can see those notches where the white areas have completely worn away. Here are the birds concerned. So here is an adult breeding plumage wood sandpiper in the month of April. And the same species, the same plumage, but this is in August, where those feathers are significantly worn and bleached. And so it looks completely different. Some species use the effects of wear to actually attain their peak breeding colors. Here is an adult curlew sandpiper in fresh alternate plumage, and you can see that all the feathers on the underparts and the head have broad pale fringes. And as the tips of these feathers wear away, the overall plumage becomes brighter. And this is not because the bird has molted its feathers, it's simply because those feathers have become gradually more abraded and worn. So here's an adult curlew sandpiper in fresh alternate plumage with those broad whitish fringes to the underparts and head. And then a bird where those feathers have become more worn, and the overall effect is that the colors become more vibrant. And another one here where we can barely see the pale fringes, and what we see is this beautiful rich chestnut on the head and the underparts. The other thing that I want to say about feather wear is it's directly correlated with the level of exposure. So we looked earlier at a tertial, and we noted how the inner web, which was covered by another tertial, was less worn than the outer web. And we can see on this great knot here feathers which are exposed to different levels of wear. So generally the more exposure, the more wear; the less exposure, the less wear. So I've just circle here the outer primaries, which as we can see are extremely worn, and the lesser coverts, which are much less worn, and they still have intact pale edges, as you can see it a bit more clearly here. They're the same plumage, the same age, but they show very different degrees of wear, and that is due to the fact that the primaries are always exposed even when the bird is perched, whereas the lesser coverts are covered by the scapulars when the bird is at rest. Also, because of the different degrees of force exerted on these feathers, when the bird is flapping, the amount of abrasion or the friction is greater on the wing tips than it is on the wing bases, because the range of movement is greater and the speed of it is greater as well. So the different degrees of wear in this case are a result of the different degrees of exposure. So we've looked at the function, the structure, and the effects of wear on feathers, and now we can look at, or we can see how we can use this information to help us to understand the age of individual birds. So because feathers become worn in somewhat predictable ways, learning how to spot feather wear helps us to age individual birds. And in this regard, being able to study good still photographs is especially helpful. It's easier to see clearly the differences in feather wear if the bird is motionless than if it's moving, although it's still possible to do this in the field. Have a look at this Nordmann's greenshank, which was photographed in late November. What we can see is that the visible wing coverts are worn, and we can see those pale spikes where the feather shaft is protruding beyond the edge of the feather. And by contrast, the rest of the upper part plumage is very fresh. So the scapulars, the inner greater coverts, the tertials. And we can see there's a contrast between the inner greater coverts and the outer greater coverts in the amount of wear. Now, if you remember back to the first video in this series, we learned that adults undergo a complete pre-basic molt, which means that their feathers are all more or less the same age. First calendar year birds undergo a partial preformative molt, where they don't molt their flight and tail feathers and some of their coverts. And so we can confidently say, because there is a clear difference in age between these two groups of feathers, that this must be a first calendar year bird. Here's a redneck stint that was photographed in October, and what we can see on this bird is that the tertials are extremely worn, and some actually have dropped out, and that the primaries are extremely bleached and worn. However, if we look at the rest of the bird, it looks rather fresh, and we don't see any juvenile feathers in the body plumage. So what we can say then is that this bird is probably a second calendar year bird in its pre-basic molt into adult basic plumage, because the primaries, the extremely worn primaries, are retained juvenile feathers. So this bird is still in its second calendar year. Another one here, another redneck stint, photographed in November, and we can see that the whole plumage looks uniform at similar age, including the tertials and primaries, and so we can say that this is an adult. We'll look at one more photograph. Let's look at one more photograph of two redneck stints, and these were photographed in April. If we look at the bird on the right, if we look carefully, what we can see is that there are two generations of feathers here. The greater coverts and tertials are significantly more worn and therefore older than the rear scapulars, which I've arrowed here. And if we think back to what we learned about molt in the first video, we learned that adults undergo a complete pre-basic molt at the end of the year, whereas first calendar year birds undergo a partial formative molt, where they don't molt their flight feathers and a number of coverts. So because this bird has two generations of feathers, one is clearly older than the other, we can say that this bird was hatched last year and therefore must be in its second calendar year, a second calendar year bird. Looking at the bird on the left, this bird appears to have much more evenly or uniformly fresh plumage, and so that makes it more likely that it underwent a complete molt at the end of last year into basic plumage, and is now renewing some of its feathers in a partial pre-alternate molt into alternate plumage. And so that would fit the pattern of an adult, so we can say that it must be an adult. Well, we have gone through a lot in this video, so I want to just summarize what we've learned. First of all, we've learned about some basic functions that feathers perform. We've looked at the structure of feathers, which may differ in shape but are similar in structure. We've looked at the need for feathers to be changed regularly and how feather wear, abrasion and bleaching, can damage feathers. And that in turn affects the appearance of feathers and plumage in predictable ways, which means that we can then use that information to help us to age individual birds. I hope this has been useful, and in the next videos we will start to look at individual plumages. That's all for this video.